students. In today's class we are going to learn how to find LCM by division method or shortcut method. In the last classes we learned to find LCM by the other two methods, by finding the multiples and by prime factorization method. What is LCM, children, once more? Least common multiple. Among the multiples, the least, the smallest among them. And the LCM of two or three numbers will be always bigger than those numbers or biggest among them. Okay? Now, and this method, today we are going to do division method or shortcut method, and this method is the easiest method and the shortest method. We have learned to find LCM by prime factorization method together. It's near about almost the same type only, but not the same. Okay, let's see how to find LCM by division method. Here the first question is, find the LCM of 12, 16 and 20 by division method. First we are going to write the numbers 12, 16 and 20. When you do the division of these numbers, in HCF we had to see whether all the numbers are divisible. But in the case of LCM, if any two of the numbers are also divisible, we can continue the process of division. And I have already told you, we have to always start from the smallest prime factor. And which is the smallest prime factor or which is the smallest prime number? That is 2. We have to see whether all the three numbers are divisible by 2 or any two of the numbers are divisible by 2. You can see here 12 is divisible by 2, 16 is also divisible by 2, 20 is also divisible by 2. It means all the three numbers are divisible by 2. We can start the process with 2. How many 2's are in 12? 2 6's are 12. How many 2's are 16? 2 8's are 16. How many 2's are 20? 2 10's are 20. Again you can see 6, 8 and 10. All the three numbers are divisible by 2. We can continue the process again by 2. How many 2's are 6? 2 3's are 6. How many 2's are 8? 2 4's are 8. How many 2's are 10? 2 5's are 10. Now we can see whether the numbers are divisible by 2. Here you can see only 4 is divisible by 2. And which is the next prime number? That is 3. Now only 3 is divisible by 3. Now next prime number is 5. Only 5 is divisible by 5. It means there is no common factor for all the three numbers, and at the same time no common factor for any two of the numbers also. So we cannot continue the process. We have to stop it here. Now how can we find out its LCM? For finding the LCM, for finding HCF, what we were doing? Only we were multiplying the numbers which are common for the numbers. But in LCM, what we will do? We will multiply the numbers which are given at the side, and also we will multiply the undivided numbers. That is 2 into 2 into, and we have to multiply these undivided numbers also. 3 into 4 into 5. You can see 2 2's are 4, 4 3's are 12, 12 4's are 48, 48 5's are 240. Our answer is 240. We can divide 240 by 12, by 16 and by 20 without leaving a remainder. We can do find the LCM of 50, 75 and 100. First we will write those numbers 50, 75 and 100. First what we have to see whether there is a common factor for all the three numbers or any two of the numbers. And we have to always see the smallest prime number. And I saw in HCF you have done with 5 first, then 2. But that is not the way. You have to start from the smallest prime factor. Here 50, 75, 100. You can see 50 and 100 both are divisible by 2. Then we have to do the process by 2. Because 2 is the smallest prime number. Now how many 2's are 5? 2 2's are 4. 1 is remaining. Now the number became 10. How many 2's are 10? 2 5's are 10. Now how many 2's are 75? 75 is not divisible by 2. 75 is not divisible by 2. So what we have to do? We have to bring this number as it is. 75 is brought down. Now 100 is divisible by 2. How many 2's are 10? 2 5's are 10. Bring down 0. Now what we have to see whether there is a common, whether 2 is a common factor for any of the two numbers. You can see 25 is not divisible by 2, 75 is not divisible by 2, only 50 is divisible by 2. Only one number is the multiple of 2. So we cannot continue the process by 2. Then we have to see the next prime number. Which is the next prime number? That is 3. We cannot divide 25 by 3. We cannot divide 50 by 3. Only 75 is divisible by 3. Only 75 is divisible by 3. Then can we continue the process? No, we cannot continue the process by 3. Then we can try with the next prime number, which is that is 5. You can see the last digit is 5, 5 and 0. So these all the three numbers are divisible by 5. Now we are going to continue the process by 5. How many 5's are 25? 5 5's are 25. How many 5's are in 7? 5 1's are 5. Remaining 2. What is after 5? 2 is balanced. The number has become 25. How many 5's are 25? 5 5's are 25. Now how many 5's are 5? 5 1's are 5. Bring down 0. 5 0's are 0. Now 5, 15, 10. Again all the three numbers are divisible by 5. We are going to continue the process by 5. How many 5's are 5? 5 1's are 5. 5 3's are 15. 5 2's are 10. 2 is a prime number, 3 is a prime number and 1 is a unique number. There is no chance of having any common factors for 1, 3 and 2. It means we cannot continue the process. These numbers are undivided numbers. Now we are going to find the LCM. First we have to multiply the common 2 into 5 into 5 multiplied by. Now we have to multiply the undivided numbers. 1, same number only will come, that's why we are not writing. 3 into 2. 2 5's are 10. 10 5's are 50. 50 3's are 150. 150 2's are 300. This is the answer of question number B. Now, I hope all of you understood, and this is the easiest method and the shortest method for finding the LCM, and all should know this method to find LCM. And here 300 can be divided by 50, 75 and 100 without leaving any remainder. I hope all of you understood. Thank you, children.